Meteor smoke makes strange clouds. Presented by Science at NASA. Anyone who's ever seen a noctilucent cloud, or NLC, would agree. They look alien. The electric blue ripples and pale tendrils of NLCs reaching across the night sky resemble something from another world. Researchers say that's not far off. A key ingredient for the mysterious clouds comes from outer space. We've detected bits of meteor smoke embedded in noctilucent clouds, reports James Russell of Hampton University, principal investigator of NASA's AIM mission to study the phenomenon. This discovery supports the theory that meteor dust is the nucleating agent around which NLCs form. Noctilucent clouds are a mystery dating back to the 19th century. Northern skywatchers first noticed them in 1885, about 2 years after the eruption of Krakatoa. Ash from the Indonesian volcano caused such splendid sunsets that evening skywatching became a worldwide pastime. One observer in particular, a German named T.W. Backhaus, noticed something odd. He stayed outside longer than most people, long enough for the twilight to fully darken, and on some nights he saw wispy filaments glowing electric blue in the black sky. Scientists of the day figured they were some manifestation of volcanic dust. Eventually, Krakatoa's ash settled, but the noctilucent clouds remained. We're still seeing them today. It seems clear now that the dust involved is not volcanic, but rather extraterrestrial. Mark Hervig of the company GATS Incorporated led the team that made the discovery. Using AIM's solar occultation for ice experiment, we found that about 3% of each ice crystal in a noctilucent cloud is meteoric, said Hervig. The inner solar system is littered with meteoroids of all shapes and sizes, from asteroid-sized chunks of rock to microscopic specks of dust. When meteoroids hit our atmosphere and burn up, they leave behind a haze of tiny particles suspended 70 kilometers to 100 kilometers above Earth's surface. It's no coincidence that NLCs form 83 kilometers high, squarely inside the meteor smoke zone. Specks of meteor smoke act as gathering points where water molecules can assemble into ice crystals. The process is called nucleation. According to AIM data, the ice crystals of NLCs range in size from 20 to 70 billionths of a meter. The small size of the crystals explains the cloud's blue color. Small particles tend to scatter short wavelengths of light, blue, more strongly than long wavelengths, red. So when a beam of sunlight hits an NLC, blue is the color that gets scattered down to Earth. Meteor smoke explains much about NLCs, but a key mystery still remains. Why are the clouds brightening and spreading? In the 19th century, NLCs were confined to high latitudes, places like Canada and Scandinavia. In recent times, however, they have been spotted as far south as Colorado and Utah. The reason, Russell believes, is climate change. One of the greenhouse gases that has become more abundant in Earth's atmosphere since the 19th century is methane. It comes from landfills, natural gas and petroleum systems, agricultural activities, and coal mining. It turns out that methane boosts NLCs. Russell explains, when methane makes its way into the upper atmosphere, it is oxidized by a complex series of reactions to form water vapor. This extra water vapor is then available to grow ice crystals for NLCs. If this idea is correct, noctilucent clouds are sort of a canary in a coal mine for one of the most important greenhouse gases. And that, says Russell, is a great reason to study them. Noctilucent clouds might look alien, but they're telling us something very important about our own planet. For more news about clouds, alien and otherwise, visit science.nasa.gov.